next presenter is Jonathan Heppner from the Quantum Biology DAO. And
Hello, hello. Yeah, this should work. Now you can hear me better? Great.
I will just share it with the teams.
We're waiting for the presentation to get set up and then uh, we get started. You can use this moment to like look up from your phones. I know it's been a long day. I'm tired myself, but not for this because I've been waiting for this moment. I've been excited for, let's say, the last 3 weeks to get to present to you guys today. And I'm going to present to you the Quantum Biology DAO. And that is, I have to click into the presentation to be able to go to the next slide. Well, that is a global community dedicated to advancing the field of quantum biology. We have raised $6.8 million to fund quantum biology, and we invested 2.8 of that already. And I want to show you how we did it because we did it in a unique and new way that is just emerging, so to say. And I think that could be interesting for you to see. It's not going to be a technical presentation like most of the presentations that we saw today. My background is philosophy, and I'm not an expert in the mathematics that you guys do. So let me show you what we do. Well, I think the main problem that we're facing in quantum biology is really creating a new branch of science. In some sense, it doesn't have the respect from mainstream physics yet. There's a lot of doubt whether it can actually work. And so what do you do when you create a branch of science? What do you need to do? Which problems are you facing and how do you overcome them? Well, let's take a lesson from history and look at this guy. In 1900, he famously came up with the quantization hypothesis. So that's Max Planck, and you probably all know him. And so how did they end up taking this hypothesis and branching the science and creating quantum mechanics? Well, they formed a community where a lot of the new and young guys that were working, like this unknown patent clerk, Einstein, who would then take up this work and create papers with it, or even younger guys who would already learn Einstein's theories in university, like Heisenberg, they would use it and create the new physics. This is in 1927. So this is this conference called the Solvay Conference. It's named after Ernest Solvay, who was a rich chemist. He had made some money with his patents that he had in chemistry. And he funded this because he cared. He knew that this was relevant because he was in chemistry. And so then I want to focus on one particular guy because this guy was also involved in creating another branch, which is forking biology. That's Erwin Schrödinger standing there behind Einstein. He wrote the book, What is Life? And that inspired the guy on the left, on the right of the stairs, that is Watson, who both Watson and Crick credit Schrödinger's book, What is Life, with helping them inspire them to build the structure of DNA. And then on the left of the stairs, we have the guy who actually inspired the work of Schrödinger by making it even possible, Max Delbrück. And I took that picture from a nice blog post that I recommend anybody who is interested in scientific branch creation to read. That is kind of the story of how molecular biology was funded by the Rockefeller Foundation is specifically one guy inside of the Rockefeller Foundation, Morgan Weaver, who kind of put the flag in this field, and he's like, oh, we're going to make that a thing. And he did that by basically funding what he called quantitative biology and then later molecular biology. And that was guys kind of just applying quantum methods to biology, including X-ray diffraction. And then that led to the discovery of DNA. So this is the picture where Watson just had presented to all the guys that he was building on. And yeah, that kind of teaches us a lesson of what the problem is and also how to overcome it. But let's first look at the real problem. So looking back at his own career, after half a century of work, Max Planck famously said that science advances one funeral at a time. He didn't actually say that, that's just a paraphrase. So what he was actually saying is this: I mean, he was suffering from this common mental disease that we might suffer from, where we think that rational argument actually convinces others to change their mind. No, he did not say that, obviously, but this is what he really said. I took that from Wikipedia, so I think that's actually true. So what he actually said, if that's worth reading, a new scientific truth does not triumph by convincing its opponents and making them see the light, but rather because its opponents eventually die and a new generation grows up that is familiar with it. So in some sense, that's a sad message. We would all believe that rational argument does convince other humans, but it turns out that People experience it, haven't experienced actually creating new branch of science, had to figure out that it was not the case. And it was actually the young guys like the Einsteins and the Heisenbergs who had not built on the past, who didn't have something to lose, who were actually the ones establishing the new field. So the gatekeepers are not necessarily going to see the light. The people with influence and power in science that can direct attention and resources are not necessarily going to buy into new ideas. So that creates the problem that the whole system that manages the resources is kind of risk averse. They don't want to build on new things because they build their careers on old things and they're working well. So why would they change? We still cite them, we still like them. They're still great scientists. So why would they change? And that creates the problem that the whole system is slow, it's bureaucratic, and quantum biology specifically kind of falls between disciplines. It's too quantum for the biologist and it's too biological for the quantum physicist. So it doesn't really make it through the panels because the basically the single discipline reviewers will both not accept what they're reading. So how can we solve this? Now, there's many ways to solve it, but some of the ways that are new and emerging is that we're going to talk about today, that these are making a contribution. So these are new tools emerging in the world of blockchain that are kind of decentralized mechanisms, tools to coordinate groups and govern groups and how they spend their money. So DeSci stands for Decentralized Science. That's communities that use open digital tools on the internet to fund and govern and coordinate research. And then we have a concept within that field, which is a DAO. That's a decentralized autonomous organization. That's quantum biology DAO. And what do DAOs do? They are autonomous organizations that use a transparent and rule-based community to make decisions together. And here, in this case, we make decisions on what science to fund in the field of quantum biology. So that's kind of what we see. We have new tools, and we have seen in the history that we need two things. We need an intelligent community, that's all of you guys, and we need funding. So on the one side of the coin, we have funding. On the other side of the coin, we have an intelligent community. On the one side of the coin, we have funding. On the other side of the coin, we have an intelligent community. So on the one side, and I think you're starting to get it, we have an intelligent community, and then we have funding. So this continues and continues. We always have the funding on the one side and the community on the other, but the quantum biology DAO sits at the intersection of both. So we bring them together in one concept through these new tools where you can at the same time own your community, so to say. You're part of the owner group and you're part of the community at once. And I want to show you a little bit how that works and what that enables. So let's talk about the funding first. So how did we raise money and in a decentralized way? So that works through these tools that I was mentioning, and one of these tools is a token. So you guys have probably heard about these tokens a lot because they are kind of viral in some sense. But how do they actually work when they work? So the thing is, what we did is we offer a token to the world. Anybody with an internet connection can buy this token. And then in step 2, we basically make it public, make an auction, anybody's buying it, and we get their currency in which we sell the token. And then in step 3, they get that token. So now you think, well, that's a good deal for us. You know, we're giving them a token and we get real currency that we can invest in science. But what do they get? What do you get if you hold a token? So that's the next slide. Basically, if you get the token, then you're not just getting an empty nothing. You're actually getting a utility that allows you to be part of the governance class of this community. So in some sense, through the token, you get voting rights that allow you to govern where the money is going that you had invested in the first place. And thereby, we basically create a market for scientific funding, so to say. So you can publicly trade it, you can use it to vote on proposals, and it's kind of tied to the underlying science that is being funded through it. And because of this link, basically the value of the token is directly linked to the science that it can enable. And of course, there's now the question, how do you make actual governance decisions? Because it's still open in some sense. And we have a 4-step process. It works like this. On step 1, we just kind of draft a proposal. We discuss it in online forums. We're using Discord. And then we kind of go back and forth, comments. People make a first draft. We comment on it. We come to a sort of consensus on what we want. And then we pass it through the first stage of voting, which is basically just making sure that we are voting, that we are aligned on what we're voting on. And then if it passes that, then we have the wording down. And so in the next step, we decide on the binding decision. So that is then a token vote where basically the people who are having a stake in the community are also the ones making the decisions. So through the token, you can basically, relative to how much tokens you hold, and that is, there's a way to weight that so it's not disproportionate, that the people who have more tokens have infinitely more influence. We make decisions, and that then decides where the grant goes. We're using the same mechanism also to govern ourselves, to like set up the internal rules and like set up new positions and whatever committees and so on. So this is how it works. And you're probably thinking, and this I want to skip because I was talking to you guys in the break. The common objection that I was getting is mostly connected to the value of the token. Most people are interested, it's like, oh, how does that have value? How is that tied to the actual IP? And I would say that that's a long thing that I cannot finish in 15 minutes. But the thing is, it's mainly about the governance rights. So make the governance valuable. That's the goal, to make it valuable, to be able to direct where the funding goes. And if you want to know more, come talk to me. If there's more than 3 people interested, we can make an online Zoom call. I'll explain it in detail. So then basically, let's go to the next slide, which is community. On the other side, we have community. So that's you guys. And what are we doing for the community? Well, first of all, let's situate the DAO. We are sitting already in a community. So the DAO is in an ecosystem where we also work together with other organizations. They are separate organizations, part of the same ecosystem. So that's the Institute. In the Institute, we have about like 7 to 9 scientists. I didn't count them well, but you can find it on the website. And they do basically the research, the hard stuff, where they research and try to link quantum to biology. And then we have an incubator that is designed to take intellectual property coming out of the research process and then spinning that out into startup and productizing what could be productized. So far, we didn't find anything that we could productize, but hopefully soon we will get there. So this is a picture of the Institute with some of the researchers there and some members of the DAO, some of the instrumentation. But I want to tell you what the Institute is doing and why this was what motivated me to join the DAO in the first place. So I met the co-founders of the DAO and also the chief scientist of the Institute. And she basically told me, and that's a paraphrase, she told me that she wants to do what Galileo did to physics, to quantum biology. So when Galileo pointed his telescope at the moon, and I knew that story well because as a philosopher, it's part of the history of science and the philosophy of science, he like pointed his telescope at the moon, saw there were imperfections on the moon, craters. And that kind of contradicted Aristotle's story that beyond the sublunar realm, there might be some imperfections, but not above. And there were imperfections. So people started not taking Aristotle's word for it, but instead looking with their own eyes at the evidence. And she said she can make a quantum microscope that potentially can show quantum effects if they are there in the cell. And I thought that's a great mission, and I wanted to join. So that's how it came about, and I joined online. We have a worldwide online availability. You just go to the Discord, and I just started participating, went to the community calls, and now they send me here to represent them. And I'm actually sleeping at one of the members' places who is not here. So it's really a global community, and it kind of seems to work. And then the next slide, we kind of host events, participating in events like with the Biophysical Society or hosting our own in Africa, where we educated a lot of students and brought together some excitement for quantum biology. We are working on a merge store, which should be launched soon. However, there are some regulatory issues in Europe, which they are kind of famous for. And then let's talk about results, because that's sort of what we do for community building a group of people who are interested. So what did we get for the money that we spent? Well, we spent 2.8 million, and that's a lot of money, but we actually also got something in return. So we got infrastructure. We got a laboratory in California. We paid the wages of the scientists, and that gave us so far 3 publications and 3 instruments that they built. Obviously, most of the time went into like first building the team. Now it's up and running, and we're going to continue to see more papers from this team. That is some pictures from the infrastructure. The good thing is we're sharing it with the Institute, even though it's a separate organization. We can host our researchers from the DAO and let them use their instruments. So that's a good thing. That I want to talk a little bit about the type of science that they do. So they investigate weak magnetic fields. Like I said, I'm not the expert in the science. You guys know more about it. The hypothesis, obviously, is the radical pair mechanism that we heard so much about in this last couple of days. And they found some early evidence. They were investigating a protein called MAGLOF2, and they found that it responds well to the effects of weak magnetic fields according to how the radical pair mechanism would predict. And they investigated E. coli and grew them in hypomagnetic conditions, and they saw that they had a prolonged lag phase. So these are some of the things that we found. They've also published some negative results on other sensitivity tests on other proteins that were not responding well to these tests. And this kind of brings us to the conclusion. Basically, we have this problem that gatekeepers are not necessarily open to new ideas because they don't have to be. And it's risk taking. And risk aversity is a real thing that even Max Planck was already observing 100 years ago, and it's still alive. So we have to kind of grow a new community of people who want to see the future. And this is what decentralized science is for. It's new tools, and you have the same problem with DeSci as you have in quantum biology, where there's going to be a lot of skeptical older people in the audience who will not want to see new mechanisms of funding, but there's going to be some people who want to see new mechanisms of funding and are actively using them. And that's basically the story. So we bring together community funding in one organization. And what we've done so far is became a leading dedicated funder in the field. We funded the Quantum Biology Institute, raised 6.8 million for quantum biology. We enabled new labs and instruments. And in all, we build a community, we have some infrastructure, and that allows us to move forward. Currently, we're mapping out the field, trying to see all the different areas. We want to branch out beyond the institute and invest in other areas of quantum biology. And we're kind of finding out what is the most promising. There's a very early version of a map that I made with Claude to just like map the whole field. And yeah, that's sort of what we're doing. Help us, join us, scrutinize the science that we have done, come into the Discord, propose new projects that we could fund, propose new things that we could put on our map and our radar. Yeah, just be part of our community, and let's make quantum biology happen and fork the scientific stack and make a new branch. So yeah, you can go to the QR code. That's the website. You can find out more there. You can join the Discord there. It has all the things that I cannot talk about in 15 minutes. With that being said, I see there's 4 seconds on the clock stopped. Just scan the QR code. That's it. Thank you, guys.
Thank you very much, Jonathan. If you don't mind, I would like to open